Okay, so on this question, a person begins at their campsite, hikes 2 straight connected paths before reaching a waterfall. North 68 west for 8 miles, and then north 49 east for 7 miles. Treat the directions, campsite starting at 0, 0, and you north, south, east, and west. What are the coordinates of the waterfall? So we just got to add those 2 vectors together, basically. So the first vector, so whenever we do a vector, remember it's always the distance or the magnitude. I'll just say m for magnitude of the vector, cosine of theta for x, and the magnitude sine theta for y. So the first vector is going to be, what does it say? 8 miles, so it's 8 cosine. Now, what's the actual angle? This is where you got to be cautious and careful. You got to get the actual angle. So what's the first vector doing? I'm going to draw it carefully here. Remember, we have north, south, east, and west, and it says it's north 68 west. So that means it was north, but 68 to the west. So it would be about right there, right? And this is 68. That's what they're saying. North 68 west. So to the north, but 68 to the west. Okay. So now, so here's the trick with these angles. So theta must be the actual bearing from 0 degrees. So in other words, you can't just say, oh, it's 68. No. It's got to be from 0 all the way to there. Remember, this is 0 degrees. This is 90 straight up, 180 here, 270 there. You got to, when you do this vector thing, you've got to, and you're doing the, m cosine theta, m sine theta, the angles have to be the actual angle. So for vectors, vector angles, the theta must be the actual bearing from 0 degrees. So you say, well, this is 68 to there, right? So it's the actual angle is going to be what? 90 plus 68, right? 90 plus 68, 90 degrees, add 68 degrees. Add that up. It's 158 degrees. It's 158 degrees. This is 8 sine of 158 degrees. See how we figured that out? So there's the first vector. We have 2 vectors here. Person hiking from their campsite. Again, whenever you do a vector, you've got to find the actual angle, the bearing angle from 0. So it was 90 plus 68 is 158. So there's the first vector. Let's do the second vector. Second vector, well, let's draw another little axis system here. We've got north, south, east, and west. And what does it say? North 49 east for 7 miles. North 49 east. So that's going to be north, but 49 to the east, about there. Right? So it's going to be about like that. Where this is 49, because it said north. Oops. 49 degrees east. Okay, so, but we have to get the actual angle, right? This is 0, this is 90, this is 180, this is 270. So what's the actual angle there? Well, it's like 90, but back up 49. So this is going to be 90 take away 49, which is 41 degrees. In other words, this right here is 41 degrees. It's actually at 41 degrees. So my vector is going to be, and how far was it? I can't remember. It was 7 miles. So it was 7 miles. So it's going to be 7 cosine 41 degrees, comma 7 sine 41 degrees. So there we've got the first vector, we got the second vector. Now we just add them together because that's what they want. They're saying, you know, he does the first part of the hike, the second part of the hike. He or she does the first part of the hike, second part of the hike, all together. What are the coordinates of the waterfall? No, to get to the waterfall, right? Before reaching the waterfall. So put the two paths together. Let's bring it on down here. So I'm going to take the 8 cosine 158, 8 sine 158, and then the second part, which was 7 cosine 41, 7 sine 41. And I'm going to add these together. So I'm going to add the x with the x. First off, let's do that. The x with the x. This is the result. This is the first vector and the second vector. And the result, add them up. Just hit the buttons on your calculator, add the x with the x. Make sure you're in degree mode. I'm getting -2.1345. And the second one, I'm going to add the y with the y. I'm getting 7.5892. And so that's the x and the y. They want you to put it in parentheses. I think I'll scribble this out. Parentheses. What's that? I think the thing said parenthesis. I remember right coming up here. Yeah, they want parentheses. 3 decimals. So there it is. There would be our answer. That's where the person ends up. They end up back 2.3 miles, 2.13 miles, and up 7.58 miles. That's how they get to the waterfall based on their 2 movements. Let's make sure that's right. 2.3, 7.58. Yep, we got the answer exactly right on the answer key there. So again, recapping, how do we do this problem? Well, when they give you a couple of directions, just turn them into vectors and add them together. How do you turn it into a vector? Well, you got to draw. So when it says north 68 west, you got to find the actual angle. So that was 90 plus 68, it's 158. And then it's 8 cosine 158, 8 sine 158. Second vector, same thing. They gave us north, but 49 to the east. So then I figured out that's actually a 41 degree angle from 0. The angles must be the actual bearing angles from 0. So that's 41 degrees, you know, from 0 to that vector, 41 degrees. They gave me 49 this way, but I always need to turn it into from 0. Whenever you do vector angles, they must be from 0, the actual bearing. So then that one was 7 cos 41, 7 sine 41, 7 miles. So you always just take the miles times the cosine of the angle, miles times the sine of the angle, but you got to have the real angle, the angle from 0, the actual bearing angle. That's the main mistake people make. Add those together to get the resultant vector on your calculator. And there we go.